security, helping organizations protect what matters most. Overall, this time we have perfected a portfolio designed to anticipate risk. We offer pen testing, red team, threat intelligence, and social engineering services. And we do so for any type of company and across any type of technology you may be using. So we understand perfectly the critical importance of cybersecurity today. So our goal is not to sell a one-size-fits-all solution, but to provide the best tailored advice based on your actual needs to generally improve your security posture. We firmly believe that true change happens when organizations embrace the concept of positive hacking, an offensive approach aimed not just at pointing out weaknesses, but at straining your security posture before a real attacker does. So to dive deeper into this and kick off today's session, I would like to hand it over to Giacomo Deneri, who is one of our experts pen testers, and he's going to be leading the talk of today. So Giacomo, whenever you're ready.
Thank you,
Welcome,
Alicia.
everyone.
Thank you for OpenSec for supporting us and sponsoring.
Thank you.
Well, welcome, everyone. Can you hear me? Can you hear me properly?
We can hear you, yes.
Oh,
We
okay,
cannot
that's
see your
amazing.
slide.
I'm sharing it right now. Well, I was sharing.
Oh, okay. All right.
Okay, I'm sharing it. Welcome, everyone. My name is Giacomo. I'm a pen tester and a red teamer part of OpenSec. And well, today we are stepping beyond the world of funny poems and simple chatbots. We are entering the era of autonomous agents. And well, as enterprise integrate agents into their core workflow, giving them access to databases, internal APIs, and decision-making power, we have created a new and massive attacking surface. And well, to understand how to break this infrastructure, we have to understand the landscape we are playing in. So, well, to understand where we are now, we have to see how were chatbots a few years ago. We have moved from stochastic parrots to the stochastic operators. 3 years ago, the threat was a user tricking a chatbot, but now a threat is an external attacker poisoning data source that an autonomous agent reads and leading to a silent infrastructure compromise. So, what does exactly makes an AI agentic? How can we define an AI as a real agent? Well, an agent is an LLM, but with hands and memory. It has 4 components, which are reasoning, planning, memory, and tool use. But reasoning, it's gonna be delegated to LLM, to a model, and the agent gonna be doing the planning, which is gonna be the step-making process to break down a goal into multiple steps. A memory, where it uses RAG to remember what it had found, and it helps to bring context to the agent's job, helping them to keep short and long-term memory for preferences, context, and past experience, and the capacity to use tools outside the agent itself. So it helps to call Python scripts or use SQL queries to execute its plan. But those 3 pillars, like planning, memory, and tool using, are target for exploitation, are going to be part of our new attacking surface. And well, what we are seeing now is the attacker's map for an AI stack. We aren't just attacking a prompt. We are attacking the user input, the external data, which is retrieved by a RAG, and the API endpoints that the agent talks to. And to ground this into a security language, let's look what the OWASP top 10 about LLM told us last year. And well, the industry standards are catching up, but we have to focus on two vectors, which are the prompt injection and the insecure plugin design, which aren't just bugs. They are breaches into the internal network from outside. But now, how can we relate it to the agents? Well, let's talk about the most famous, which is the direct prompt injection, which is mostly an from door attack. We are going to be attacking from the user input using some kind of attacks like adversarial suffixes, like using GCG, which is based on using symbols on additional strings like exclamation and question mark to force the model to bypass its filters. Another way, the payload splitting, which will divide the malicious content into small pieces which will seems like non-harmful for the agent, but when they get together, they build a malicious payload. And the virtualization forcing the model to move from a user mode into a developer mode or jailbreak state, so the user can start playing outside the roles that the agent had been made. And the translation attacks, which are obfuscation, the malicious intent, but by asking the model to process instruction in a low resource language, which is like mostly the most common that the non-technical users use, which is trying to just saying to the agent, I'm doing this for educational purpose, and trying to make it think that what they are doing is not harmful. Let's move to another way to inject prompt, which is the indirect prompt injection, which differs from the first one in the meaning that we can consider this like a silent hijack, where the attack doesn't talk directly with the AI to attack it, but they'll leave landmines in PDF or websites where the agent searches to make an agent search information and force them to interact with those landmines, make them ingest them with the malicious instruction, which are going to be executed then by the agents inside the agentic loop. This leads to the most dangerous part, which is the attacking agentic loop. But what is the attacking the agentic loop? We have to understand that now we are moving from attacking a word choice to attack a decision logic. And our first step to understand this process is the tool hijacking. And in tool hijacking, we can understand that the agent gonna use tools to interact with the world. So if we can control its parameters for those tools, we gotta win. For example, if an agent is running an run SQL tool, we can understand that it's running queries for an SQL server. So we can try to run a drop table instead of a select, like in our lab. In our lab that we are gonna see next, we saw that with a search predictive area tool, we poison it to ingest a file, a poison file, will let us to run a shell. Another kind of attacks is the recursing calls, forcing the agent into an infinite loop, causing resource exhaustion, which is mostly a DDoS attack. The data exfiltration, which is manipulating the outputs to exclude sensitive data by trying to read protected files, which shouldn't be obtained from the external user, or bypassing the UI, which is directly interacting with the APIs. This last part, which is bypassing the UI, is going to be possible because multiple of the endpoints that uses the agents are lacking from a hard authentication process. So this last part is kind of a hard problem for agents now. And then, well, we have to talk about privilege escalation, since what the goal from hijacking tools is to obtain a process, to begin the process from privilege escalation. Now that we had hijacked a tool, we gotta start escalating privileges. But we have to understand that AI agents are often overprivileged. Often developers give the agent a broad of API keys just to make them work. Oh, Alicia, do you have something?
Yeah, I'm sorry. Giacomo, do you mind turning on your camera, please?
My camera?
Yeah, please.
I can instead of
You don't have permissions.
yeah, I didn't have permissions.
I don't know if
Let me,
maybe
I'm
Martin
checking,
or
I'm checking continue.
Thank you.
Okay. Well, let's continue. So often developers gonna give the agents a lot of access to API keys just to make them work properly. But we want to move from a restricted user scope into an agent scope. So this overprivileged API key is gonna help us to reach this goal. And the way to do this is by poisoning the brain's library, which is the vector that DB. There are multiple ways to interact with the brain of the agent. We can start interacting with RAG by infiltrating the vector database, and we can perform a semantic injection, which is inserting documents into a knowledge base that is semantically close to likely queries, but with certain false or malicious instructions. So in this case, when the agent gonna read this, gonna try to find its memory, gonna find some malicious process, which is gonna let it into a bad behavior. Same with knowledge corruption, which gradually pollute the vector store to influence long-term memory, like reasoning and corporate policy enforcement, to don't work properly. And at this point, we have to understand that a, this is not just a model risk. This is an infrastructure risk. And after this, we have to talk about the system prompt leakage. Since the system prompt is the agent core identity, if we leak this, if we can obtain how does the guardrails are protecting the agent to don't let it to prevent it from unsafe outputs or prevent some words or even the reconstruction attacks we try to return what the agent is doing via text, just trying to make it expose its code, or the IP theft where attackers try to steal intellectual data which is protected by the user with a way to mitigate this is implementing strict output filters that will block the echoing of the system level. So the main goal to prevent it is to try to avoid the user interact deeply with the core of the agent and avoid the agent to reply to the system level context. And
Giacomo,
well,
try the video, see if it works now. Sorry to
okay.
interrupt. All right.
Can you see me?
Yeah, we can
Okay.
see you.
Okay, that's better now. Thanks, you. And well, now we have to talk about the OWASP top 10. After OWASP made the top 10 for LLMs, we got the top 10 for Agentic AI. And let's look at the first category. We got agent goal hijacking, which is in simple language means an injection. So now, how do we stop it? How can we deal with it? So, welcome to a defensive architecture. And at this point, we cannot rely that the agents and LLMs are nice. We have to assume that they are compromised, that we have to find a way to defend from outside. And our first line of defense is the sanitization. What is it? Well, wait. Okay. To understand how can we how can we sanitize the input, we have to understand a dual agent approach, where a first agent is gonna be a guardrail trying to avoid malicious inputs or malicious outputs to reach the agent or the user. When this guardrail finds that the model is trying to perform a malicious code or return a malicious output, it's gonna kill the process. But if not, it's gonna allow a second agent to complete the task that the user was asking. But software will always have bugs, and we need runtime isolation. So we have to understand that every tool must be in a prison. We cannot let them interact between them freely. So never run agent tools on the host operative system. We have to use Docker containers like gvisor, Firecracker, or micro VMs. Because why? Because if the agent is tricked into running a remote folder from the root, we could be saving our entire system from destroy everything to just destroying a temporary sandbox. So running those tools on isolated containers will help us to save our systems. For the most sensitive task, for those tasks that are the most important, we need a human. We need a human in the loop. But why? Well, we have to understand everyone loves efficiency, but efficiency is the enemy of cybersecurity or security itself. For high stakes actions like wire transfers, deleting users, changing permission, we must pause and wait for a human okay. This is the only way we can stop autonomous hijacking. And to catch those attacks that we will or could slip through all those defenses, we need an specialized monitoring. So we have to monitor two aspects: the token velocity and the semantic drift. The token velocity, why? Because sudden spikes for recursive loop are gonna be a signal from a malicious use. So it's a metric type that we have to keep considering during the process. And the other one is a semantic drift. Because why? Well, a common agent that is supposed to be helping on daily processes won't need to interact with sensitive data. So if we find some sudden shift to system or admin topics from an agent that shouldn't be working with those, it's gonna be an adversarial signal. So we have to keep that in mind during the monitoring and finding anomalous processes. Well, let's talk about the future of red team, because static testing is dead. In a traditional infrastructure, a vulnerability stays a vulnerability until you fix the code. In AI system, the vulnerability surface is a non-deterministic. A model that is perfectly secure against a specific jailbreak today might fail tomorrow. Determiner shifts in system prompts, data context, or a minor version update on an underlying library. We have tools like Pirate from Microsoft, which is a good option to simulate an active persistent threat actor trying to pivot into the backend API or execute unauthorized tools. Augustus from Praetorian is another good light option from LLM vulnerabilities scanner. So we have to keep that in mind. We need continuous and autonomous red team to use tools like Git Shark or Microsoft Pirate to consistently bombard those agentic systems with new jailbreaks, variant to find weaknesses before the attackers do. So this will let us bring to the end, but we have to find just overlap in this image. We want to see that we have a small LLM model, which is an Llama on Py3, an agent with some tools and some vulnerable in several ways, but is not fully vulnerable, a simple API key, and a malicious actor using a Kali Linux. So we're gonna try to do some arbitrary file reading. We were prompting the agent into trying to read some instructions, and well, we're gonna try to ask it to find some malicious data, some information that we shouldn't be able to obtain. As a reply, well, it replies us some sensitive information, which in this case is a CDF flag. And the user interface is where we are gonna be asking from the user with the agent. And then we are asking about, for example, a protective area. And at this point, how can we know about a productive area before? We need a reconnaissance process. The reconnaissance, a learning before it process, is gonna help us to understand how does those agents work and how can we ask them properly to try to find some additional information during the process. Then we're trying to consume an internal API just to check the status from an endpoint, but it didn't work. It didn't leak something interesting during the process. But we are consuming internal API. We're going to be trying to check some information. But at this point, we found some interesting information. We got connection to the API, but it was not our first attempt. We have to try it multiple times in order to find a way how to ask or how to bypass its guardrails to obtain what we were asking the agent to do. At this point, we have to check, for example, if the status failed, we gotta use internal service request to perform a deep scan from admin secrets. Not anymore work. Not everyone works even when you know how to use the tool right. So we have to understand how does the tool works to try to ask it properly to bypass security processes and trying to obtain the data we are trying to ask the agent to get back to us. And then we are asking if there are some hiding secrets under the admin endpoint, and asking it to bring it back to us. And why? Because we know that most of the endpoints gonna have always an admin directory. It's like a must-have for endpoints to have an admin directory to manage its processes, to manage how does the API works. So then we try to find even more information, and at this point we gotta find the secret that we were asking for the agent at the beginning of the process. Well, then we have to retrieve some Poison data where we're gonna ask if we're gonna say the system that there is a new update and asking it to try to find a new update from outside its file or outside its library. So there was no command execution. The idea was good, but there was no command execution implemented inside the agent. So we asked it to execute a command from outside, trying to connect from an external server, which was our attacker system, running a malware script and asking it to run it with bash. So at the beginning, we found that it was not expected that it was going to work, but it worked. But the guardrails were working as expected. Even a small LLM, which is which should be easier to bypass, has some security systems, some guardrail which will stop us from running some malicious code inside the system. But if we get the RCE trying to modify its policy with a good kind of prompt, we gotta find a way to bypass those guardrails. And in this way, since you see, we gotta run the core command to our attacker system, running a bash, and gonna be pound just an echo from outside. It was a string pound. The best advice when trying to run something is to try the most simple ways. And when we try to give even more specific information, those guardrails will be more probable to detect us and block our prompts. At this point, we run the script, the RC, and then we're running commands inside the AI agent as inside the AI agent as root. As you can see, we are running as root those commands inside the agent. Because why? As we told during the explanation, most of the time those agents are also overprivileged. So most of the time, if we pound them, we're gonna be running as a root. So what does those slide doesn't show? Well, not all models are the same, of course, but size matters always. Not because Pi3 is a small LLM is easy to abuse. In small LLMs, some elements are easy to control. There is no general receiver to interact with an agent or a model. It doesn't matter if the agent implements their own tools or own use tools by an MCP. The agent's reason using something that is probabilistic is the model. You have to understand that most of the time we are not going to have the same answer even asking the same question. And the previous knowledge about orchestration of the source code is more valuable than traditional security breaking techniques. You can easily find a blind SQL injection to conduct a coercion attack because that's analysis deterministic. But only in sci-fi, the sci-fi world, you have access to the source code of everything. So we say at the beginning of this demo, reconnaissance is always the better way to understand how those agents work before we try to interact with prompts directly with them. Well, I don't know if you have any question. That brings us to the end of the presentation. Thanks you.
Thank you, Giacomo. This was really informational and full of extra information that I didn't know. So hopefully it was beneficial for all the rest of the attendees. If anyone has a question, you can either type it in the chat window, and if not, you can unmute yourself and ask the question live. Doug McCaber is asking, what is a skitty?
Oh, this kid is yeah, it's a kid running scripts without knowing how those scripts work properly. So it's that.
All right. Any questions? All right. Looks like I'm not hearing any questions. And okay, there's one question. You can see the question, Giacomo?
Yeah, I can say it.
Okay.
Same. Well, as I said, we should use an agent. Well, we have to split a main agent into two agents. One will be the guardrail, which will validate the input and output before it reaches the user or it reaches the agent worker itself. So a good way to sanitize data before it reaching the system is by using a guardrail, an agent guardrail to validate input and output.
All right. Any other questions for Giacomo? Okay. Well, looks like I don't see any questions typed. Last call. Alicia, do you have any closing comments?
Well, just to thank you again for the space to share what we know. We like a lot to share with the community, and also with OWASP LA. We have a special how can I say it?
Relationship, bond, yeah.
Yeah.
We're family now.
Yeah.
Okay, well,
So
thanks again for
thank
your
you.
sponsorship.
Edmond,
Really appreciate it.
also talk about the raffle.
Oh, so why don't you talk about it, Martin?
So automatically those who attended today, they're part of the raffle now. We have
Okay,
a
all right.
layer one ticket for this upcoming weekend. So
Yeah, so we're giving away a free ticket to layer one. By attending today, you are entered into the raffle. You can increase your chances by liking and reposting some of our LinkedIn and etc. posts. So check out for our posts and participate, so you'll have a better chance to win the raffle. Yeah, good luck to everyone. Okay, thanks again for everyone to give us some time and support our community and attending this meeting. The recording would be posted shortly along with with the slide deck. With that, I'm going to close the call. See you all next time. Don't forget, our next in-person meeting is going to be Wednesday, the 27th of this month. Look for the details in Luma. Bye, everyone.
Bye bye.
Bye. Thank you.